we've focused today's webinar on maximizing stand establishment, and as I mentioned, we have two presenters today, Neil Harker, who's involved with weed management research and sustainable production systems with Agriculture and Agri-Food Canada. He's going to start off the first half of the presentation for about a half an hour or so, and then Doug Moisey, our senior agronomy specialist, one of our senior agronomy specialists, who's based in Alberta, will take over and cover some additional topics around stand establishment to finish out the presentation. So with that, I guess I will turn things over to Neil and let him take over.
Okay, thanks Derwin, and thanks to everyone for attending this webinar. It's good to be here with Doug Moisey. He knows a lot about this, so any questions you have, we might have to refer to Doug, but we'll see what we can do. So what we're going to cover are two areas. I'm basically going to talk about stand establishment from a cause and effect type situation and some of the experiments we've been doing. Doug will talk more about some of the consequences of poor stand establishment, and so that's the order in which we'll go. Sometimes we get the opinion that all we have to do is choose the right variety and then all will be well, but with stand establishment in such a small, tender plant as canola, there's lots that we can do to manage other than just buying the right variety, although those varieties are good and important. It's a little bit shocking when we look at average canola emergence. In the experiments that I averaged over, there were 8 site years, 40 treatments. And if we look at what the percentage of seeds emerged is, it's a lot lower than what you might think. And in these experiments, which were done in some very wet and some very dry years, it only averaged 30%. Most of our other experiments are up around 50, but so it can be a lot lower than you might think. We asked Bernie Hill out of Lethbridge to take his neural net model and predict using soil parameters and environmental parameters how much canola might emerge, and so his neural net program came up with some answers. He looked at soil type, soil texture, pH, soil temperature, growing degree days, latitude, soil organic matter, and none of those were very important. Interestingly, the 1, 2, and 3 reasons or explanations for canola emergence were precipitation 1 week before seeding, precipitation 2 weeks before seeding, precipitation 1 week after seeding. So unfortunately, you can't really control that, but it puts into context some of the other things that we do. So as I mentioned, canola is a pretty weak seedling initially, and the seed, if it's not planted or placed carefully, is susceptible to poor emergence. So here's an example in this next slide of poor placement of fertilizer, and this is probably from going a little bit too fast or maybe worn openers. You can see on the bottom right arrow where the seed should be up on the shelf, and the arrow is pointing to one little seed there. On the left, you see seeds where they shouldn't be down in the fertilizer row right with the fertilizer, and that can cause some issues. So despite the fact that that's really good seed and high germination capability and good vigor, it won't be if it's put that close to fertilizer. Here's a picture that Doug took of some issues with placement and speed, and showing some poor stands in canola. Here's an experiment that we were doing showing that what happens when you place urea right with the seed. And this is only 30 pounds of nitrogen in the seed row, and yet we're getting some problems in every other row here, where, especially in every other row, where we get some poor emergence. If we simply coat that seed with polymer, ESN, polymer coated N, it changes quite dramatically and improves quite dramatically. Here, in a very vigorous crop, this isn't canola, but this is barley, and it shows you what can happen even in barley. So this is a lot of N in the seed row on the left, and this is when when it's banded below and beside it on the right. And the reason I show this is that it has implications for weed management, which I'll mention a little later in canola. You can imagine that the weeds will do better in the canopy on the left than on the right. And indeed, that was the case when we went to take wild oat biomass. That canopy that was poor a little more than a month later led to 5 times more wild oat biomass than the other canopy, and required an additional unnecessary herbicide application. So back to this canola emergence. When we have done these experiments, I mentioned that we get somewhere around 50% emergence on average, and you can see if we look at the treatments on the left here, going slow and planting shallow, we can do better than 50%. If we go fast and a little too deep, we do worse than 50%. So that's what got us interested in this study of doing seeding speed and seeding depth, and I'll show more data from that in a few minutes. First, I'll show you some of the pictures from some of the plots. You've got what we'd call more of an not ideal, but a speed and a depth that makes it easy for the canola to do well. Your particular openers or equipment and land may allow you to go faster than that, but we wanted to show both ends here. So here's going slow and shallow. Here's going fast and deep with an OP cultivar. This is an RR open pollinated cultivar. You'll see in the next slide that can improve quite a bit just by planting a hybrid, but there's still holes in the canopy when you look at it from a top-down situation. And what happens often when you go a little bit too fast is the seed that's planted in the front shanks, the front part of the toolbar gets covered a little more heavily when the soil is thrown, and it actually gets deeper. So you get this every other row not coming up well. It's more deeply buried than what you set your seeder for, and that can cause some problems. This shows a hybrid. On both slides, they're going slow, 4 miles per hour. One's planted, though, at 1 centimeter on the left, and the other's planted at 4. And the problem is this is not always with yield. If you have great weed control and you're willing to put on another herbicide, you can yield this as well. But the second herbicide costs you inputs, and it not only costs you inputs, but it can give you unnecessary selection pressure for weed resistance, which is a problem that I'll mention in a little bit. And so the most effective way to delay weed resistance is just to use herbicide less often. So if you have a more competitive stand, you won't have to use so many herbicides, and especially the additional unnecessary ones if you're careful with your stand. This is from a New York Times article, but it suggests the importance of glyphosate as a herbicide that's worth preserving. And so the statement by Stephen Powles out of Australia is saying that glyphosate is important for, as important for reliable global food production as penicillin is for disease. But with price pressures and generics coming in, the price of Roundup keeps going down. So despite the fact that we urge people to use less and alternate with other herbicides, it's getting difficult to do that from an economic point of view. Here's what's happening in the southern U.S. where they've used glyphosate over and over with very heavy selection pressure. This is the #1 weed in cotton, Palmer amaranth, which is now glyphosate resistant. You can see why it got there and how quickly it got there. 4 fields of continuous cotton for more than 6 years, nothing else other than RR cotton. And here's the herbicide regimes. They put it on as a burn-off and then 3 to 4 times in crop, and all of those times are twice the application rate that we'd use in canola. So it's no surprise that they soon got resistance to Palmer amaranth, and now it's in many other states as well, and I'll show you in the next slide how fast that is spreading. So here's a map of the United States, and I'll just show glyphosate-resistant weeds. And as we go around in a circle around, Italian ryegrass in Arkansas, Mississippi, kochia, which is a big weed in Canada, of course, is now resistant to glyphosate in Kansas. Rigid ryegrass, California, hairy fleabane, California. And by the way, the yellow arrow in California means it's resistant not only to glyphosate, but another mode of action. Here's the first perennial grass resistant to glyphosate. So this is the counterpart to something like quackgrass up in our area. This is Johnson grass in the U.S., in Arkansas, resistant to glyphosate. Another grass, goosegrass in Mississippi. Annual bluegrass in Missouri. Now some weeds that have several states. Common ragweed in Ohio, resistant to 2 modes of action, one being glyphosate. Here's tall water hemp, and in Missouri the red arrow indicates it's resistant to glyphosate plus 2 other herbicide modes of action. Here's giant ragweed. The green arrow indicates the first resistance in Canada. We now have glyphosate-resistant giant ragweed in southern Ontario. Amaranthus palmeri, the big cottonweed, and the biggest glyphosate-resistant weed in terms of number of states is horseweed. And so you can see there's a concentration on this map, and it's all in one area and not in much of the other. In this blue area are some states that have not yet have confirmed glyphosate resistance, but just as a note, this kochia, scoparia, or kochia that's resistant to glyphosate in Kansas has also been suspected in Nebraska, South Dakota, North Dakota, Wyoming, and Colorado, although not yet confirmed. So it's coming right close to our borders, and unfortunately it blows around with the wind too. So this is a serious issue, and it's one of the reasons we talk about having a good stand so you don't have to put on unnecessary herbicides, because we don't want to select for resistance unless we have to. I want to talk a little bit about the effect of light on weeds, and in particular weed seed germination. In this slide, you can see that that many weeds germinate much better in the light than in the dark, so a much higher germination for all these species. And over here, it's much reduced by germinating under dark conditions. This is a little more interesting. This next study I'll show are these 3 weed species that aren't really common here, but they show a principle. These species germinate perhaps a little less in the dark than in the light, but what's more interesting is they almost don't germinate at all if they detect that there's a plant canopy above them. And so this was a very simple experiment where they wrapped some leaves around a petri dish, and these seeds thought that there was a plant canopy above them. And so they didn't germinate at all, showing the importance of developing a good crop canopy. Well, you'll say that perhaps these weeds aren't that important for Canada, but here's one that is. This is dandelion, and we've got a similar experiment here. Plant canopies, these are actual plant canopies seen in red down here, rhubarb, rye, barley, dense currant, and wild shrubs. So they're actual canopies, and this shows how dandelion germinates under those canopies or in a diffuse indirect light source. So that's like light coming in a window but not direct sunlight. So you see with diffuse light, dandelion germinates very well after 4 days, 64%, and then up above 80 in 8 or 12. But if the seed feels or detects by the light quality that there is a plant canopy above it, it hardly germinates at all. And so that has implications for whether or not you'll need herbicides, and it's an implication for careful seeding. You can see with hybrid canola varieties here that we can close the canopy a little faster than what we're used to with some of the open pollinating cultivars, and so that that can result in less herbicide use. Here's a study we did a few years ago showing 3 different cultivars. This is an OP Rapa cultivar, Hyson 110. The old Q2, which is one of the first Roundup Ready lines. And here's Invigor, which is, this is Invigor 2153, which many of you will remember. But what we're looking at here is how fast they close the canopy. So, and these dates from June 5th to June 26th. And you'll note that at every date, the hybrid has more canopy. Here, twice as much as the OP, and maybe not twice as much later on, but much more canopy. And that allows us to apply less herbicides because the weeds will not grow as well. This just shows a picture of what it looks like from a top, kind of a side view. Much more leaf area with the hybrid and bigger than the open pollinated seed, where even when they're planted on the same day. So now I'll get to showing a little bit of actual emergence data from some of these experiments, and I'll take just a minute to explain these graphs, because you'll see these tables. You'll see a lot of them. So first of all of these experiments were planted at 150 seeds per meter squared. And so when we're looking at the body of the table here, anything that emerged at least 75 seeds out of the 150, or over 50% emergence, is in black. And anything that's less than 50% emergence, or less than 75 seeds, is in red. Now the other color coding here is that this is the ideal treatment, 4 miles per hour at 1 centimeter, or the ideal in these experiments, not necessarily on your farm. And anything that's less, significantly less, using statistics, than this ideal is in yellow. And if it's greater than that, it'll be in green. So in this slide, you can see that there are some emergence values that are less than this 4 miles per hour, the slow and shallow. So in 2008, quite a bit less than 100, down to 61. In 2009, anytime we went deep at 4 centimeters, whether it was slow or fast, we were below this slow and shallow. And then here was another one that dropped down. I've also put some rainfall data in here. So this is the 3 weeks surrounding seeding. So 1 week before seeding all the way to 2 weeks after. And anytime that was at least an inch or 25 centimeters, that's in blue. When it's less, it's in orange. So that gives you an idea of the rainfall conditions which have such a big impact. Now, if we're looking at Lethbridge, some interesting thing happens. We have some green highlighting here. And here it even went a little bit above 50%, or just barely above 50%. But in 2008, you'll note that this is an extremely wet year. We had over 3 inches of rain in the 3 weeks surrounding seeding. And so that caused some excitement. And probably the plot that was seeded the shallowest, in actual fact, came up the best. Because sometimes when you go at 7 miles per hour, the drill kind of floats out of the ground a little bit, and it's really not even a centimeter. So under real wet conditions, it was better to be close to the surface than sitting in a waterlogged soil down below. Then we go to a fairly dry year, and then here's where it was seeded to moisture. It missed the moisture in some of these others, and so it came up a little better. Indian Head, these numbers I'm not really confident in because they're so high. I think we really got more than 150 seeds in the ground. So I find it hard to believe we'd be over 90% emergence. We've never observed that before. But of the one case that was significantly lower than the ideal, it was planted fast and deep. And it was on a fairly dry year. But Scott, we had some very interesting things going on. This is almost the hottest of all, or the driest of all the site years. Only 10 millimeters of moisture that came for the 3 weeks surrounding planting. And so whenever we seeded to moisture at 4 centimeters, we did well. In fact, we're higher than going slow and shallow. And so that tells you that the so-called recipe approach, that you're always better to go slow and shallow. If you're in an area where you don't expect much rainfall and it's not common from year to year, you might be better to go a little deeper to look for moisture if there's none in the forecast. Here it goes the other way. A very wet year, as most of you remember last year, we're close to 4 inches of rain around seeding here. And anytime you put it deep in the ground, you lost a lot of that seed. And so Slow and shallow works pretty good in most cases, but you can't look at it as a recipe. And so with that, I think I'm ready for Mr. Moisey, but I guess, Derwin, perhaps if there's any questions at this point, we can work on them right now for a couple minutes.
Sure, that sounds great. Haven't had too many come in, but we did have one question from Gregory about your map of where glyphosate resistance in the U.S. has been showing up, and just looking for some insights into the factors that are contributing to the higher levels of resistance. And the example they used was the Mississippi Basin appears to have a higher frequency of glyphosate-resistant weeds showing up. So what might some of the factors be contributing to that?
Okay, that's a great question. The main factor is the prevalence of RR crops. So Mississippi Basin, we've got RR corn, RR soybeans, RR cotton, and they're often grown without any breaks. And anytime you do that, you're in trouble. And so it's just a matter of selection pressure. In cotton, as I showed, you can put on glyphosate 3 to 4 times a year. In corn and soybeans, you put it on at least twice and sometimes 3 times. And so incredible selection pressure and very little diversity in crop rotation. Even though they rotate from a corn to a soybean to a cotton, there is no herbicide rotation because it's all RR. And so the open parts of the states just reflect basically less RR crop intensity. So that's why I would say, that's why I wanted to show that, was because it suggests that even when we are with an RR crop, if we have a good canopy, the second application of Roundup isn't going to be useful or necessary if we have a good crop canopy.
Great, thanks, Neil. We just had one more question come through, and then we'll maybe turn things over to Doug and open it up again at the end. But it was a question from Réjean here in Manitoba, and he was just asking if we have any emergence percentage values for other areas like Manitoba. And the reason he was wondering is with generally more moist conditions here in Manitoba relative to some areas in Saskatchewan and Alberta, would there be a difference?
Fortunately, the first few years we did this, it was in Alberta and Saskatchewan, but then Manitoba canola growers jumped on board with the Prairie Canola Agreement and now the Canola Cluster. And this year we will just be initiating some new work that will be across all 3 provinces. And so we'll have both in farm fields on a demo type level and as research. And the other thing that I didn't mention is that study will be a little better than our previous one because we'll not only look at seeding speed, but we'll look at different openers. And the openers we used in all our studies were just a Conservapac, probably about a 1/2 inch wide knife. And so this new study that'll be in Manitoba as well will be more broad and give us some more data on that.
Great. Thanks, Neil. I see Doug's got his slides up and running. Hopefully everyone can see them. Just before we turn things over to Doug, the other thing I'll mention that I didn't mention at the start of the presentations was we were able to get approval for CCA credits. So just to let everybody know how that's going to work, there's a code embedded toward the end of the presentation, and I'll share more information about how to submit for the CCA credits. But just to let you know, there are some available, so stick around. So we'll turn it over to you, Doug.
Sounds good. Everybody, I hope, can hear me. Can you hear me, Derwin? Derwin, can you hear me?
Yep, I can hear you loud and clear.
Perfect.
Yep,
okay.
You bet.
Just to start, I would say, number one, thanks, Neil. It was a great lead into where we're going to go for the rest of the morning here. I will like to add to the point is that at the Scott research, Neil showed you the depth of seeding under dry conditions and chasing moisture helped. The one thing is a good suggestion, though, is that if you are in those drier climes and you are going to be chasing moisture in the middle or later part of May, it still wouldn't hurt to pump up your seeding rates. One thing I would suggest is that maybe 5 to 10% would be a pretty good number to start with, just because of that lack of emergence that you will get potentially from going too deep. So just to add to that. So I'm going to continue on with some of the research that was continued at the site, just looking at days to emergence. And the one thing I wanted to point out was the yellow means that there is some difference there, and it is significant. And looking at Lethbridge, from an example, 2008, we see that by going in at that 7 miles per hour at 4 centimeters of depth, we are seeing days to emergence being about a day later. How that translates out in the fall time, if we look at the old adage, a day in the springs were 2 in the fall, it could translate out to a couple days later. But then you combine the fact is that if you have lower plant stands, that could even extend that even farther out. And so we do see that in Lethbridge in 2008, we have that if you do everything wrong, we have that later emergence. Conversely, add into 2009, for some reason we see that 7 miles an hour, 1 centimeter depth is showing us that typical 1 day later. But again, I don't know what's going on there, and even myself and Neil have talked, we just can't figure out why that was like that. We go move over to Indian Head. This is where we really see some big differences by seeding deep, how much we are actually affecting our days to emergence. And I think the telltale sign here, if we look at 2008 especially, we see almost a 9-day difference, and going from 1 centimeter down to 4 centimeters. And then on the 7 mile per hour treatments, we're seeing almost a 10-day difference. That probably is in conjunction to the colder spring, the colder soils, which typically when you have colder soils results in a little bit slower germination and emergence issues. When we throw into 2010, we see that we are almost getting this 2 and 3 days difference. And in 2010, as we saw in the fall last year, in August and September with the cooler days, we weren't quite getting the heat units we wanted, the sunlight. How that translated out in the fall can make a big difference for producers, especially if we start going too deep. And so this is why when we stress that 1 centimeter, that 3/4 to 1 inch on average, this is why it shows up to be very important. If we go over to Scott in 2008 and 2009, actually the reverse trend happens. By seeding a little bit deeper, we're actually able to achieve earlier emergence, although not significant, but it shows the value of having moisture, the seed sitting in the moisture. 2009, not much difference, but when we go into 2010, we can see that deep seeding again played a big role with all the rain as how much later it was emerging. And again, when we start looking at 2 and 3 days, this can be significant at the end of the year. What the interesting part is that we see that 7 miles an hour at 1 centimeter turns out to be actually the earliest of the emergence, and the question has been raised before is this a function of the fact is that as you get faster, you actually get a drafting issue where maybe we're a little bit shallower. And so those are the kind of things we have to be thinking about, but we do see is that just by going too deep, that is an issue. When we start looking at the yields, if you take a look at 2008, we see that typically at 4 miles an hour, 1 centimeter in 2008 gave us our highest yields, although not significant, because when we look down the bottom bar, our least significant difference is 10. So significantly, it's not under scientific, but we're looking at the picture, we are getting better yields. 09 is probably the more telltale sign, is that we see that in 2009 we have, by doing everything right, we look at the yield we have an actual yield bump of anywhere from 10 to 14 bushels. So, are you hearing me okay, Derwin? Hello?
Yeah, coming through loud and clear.
Okay, because my screen popped up saying we're experiencing network issues, so. Anyways, when we go to 2010, we see that really not much difference in yield. And when we take a look at the year at Lacombe, very wet conditions, good rainfall amounts. We had a pretty good growing season, pretty good this year. And so we do see some differences at the 7 mile an hour, but not significant. But the idea again is take a look, we are seeing some yield bumps and yield changes going on just by not doing things right. Well, going on there? When we roll over to Lethbridge, we can see here that the bushels per acre, we're not seeing much difference in the various treatments. But again, Lethbridge again in 2008, 2009, very wet years. Just some conditions just cannot explain it. If we actually look at it here by going 7 miles an hour and 2 inches deep or 1.5 inches deep, it gives us our highest yield, but not significant. But it shows you how sometimes just the trends don't quite show up to what we see for plant stands. Indian Head, we see the same things going on as far as yield is concerned, really not really significant, but we do see in 2010, we do see that we do get a good yield bump by having everything done right. 2009, we have a little bit of variation, but the idea is that it really wasn't significant. But we're showing you the yields and how it can be variable across different sites. Green seed, which is a quality issue when we start looking at into harvest, green seed becomes more of an issue in that end as far as economics are concerned. And when we take a look at green seed issues in Lethbridge in 2008, we are seeing is that, you know, all the treatments, although grading anywhere, all grading a number 2, you do see that the green seed percentage is changing. Don't understand why 4 mile per hour versus 4 has actually 1% less green seed, but they all did grade a number 2. In 2009, we do see is that those different treatments are all grading number 1. Probably the interesting one is Indian head here, where we have, by doing it right, at the right depth, we get a number 1. By changing things up, going to 4 miles an hour versus at 4 centimeters, we see we go to a grade 2. 7 miles an hour at 1 centimeter, go to a grade 3 and back to a grade 2 again. When we look at 2010, we see that there is percentage green seed difference, and I think the telltale sign is looking at the year. By doing things right, we were able to achieve a number 2, but when we did things wrong, we were into a grade 3, which can be a substantial economic loss if we're looking at a whole farm approach. So this is why it's important to do things right. If we look at 2008 and 2009, 2010 into Scott, we see that although in 09 and 10 not much difference, but we do see a difference in 2009, whereby going at our 4 miles an hour slow at the proper depth, we actually achieved a number 2. And when we did do things right, we were at grade 3. And when we start looking at $1 per bushel or more, it starts adding up over time. So as far as the data is concerned, it is showing some trend lines as far as being is that if we're not paying attention to some of the details, we may pay for it in plant stands up front, and we may pay for it at the end of the season. And so it's really important that we take a look at how we're doing things at the beginning of the season. So moving on, let's look at day 1 of seeding. And I think this is where we start to lose, this is where it becomes very critical. The common theory is we do lose a lot of yield potential in our first 20 days of seeding that has been talked about before. And so it's really important, I think, we start off with doing things right. Our agronomy survey that we conducted through the Canola Council 2 years ago showed that basically gave back to us 50% of producers have an income loss due to poor plant stands in the last 5 years. And when we start looking at getting a long-term yield average up higher, when we're having 50% of our producers had some income loss due to poor plant stands, it's important that we have to start thinking what's going on in the first couple of days of seeding. There are many factors that affect canola yield, and you can take a look here by the screen here. There's all these different effects from field to soil to seedbed firmness, days to frost-free, wind velocity, relative humidity, rain, snow. They all play roles in how we get yield. But when we look at plant populations and how they're affected, we have to take a look at what is things that we can control. When we're talking to look at taking a plant population in that targeting 10 plants per square foot, we cannot control our environment. What is up to us to do is to maximize our management practices in order to get the most out of the moisture that we do have in the environmental conditions that we are dealing with. From a seed quality end of it, the seed companies are doing the best possible job to get you the best possible seed into your hands. But again, you are still putting a very small seed into a very harsh environment. And so what we have to look at is managing how we look at our crop residues, how we look at our herbicide residues, pests, soil characteristics, and seeding practices. And this is probably where we can grab the most bang for our buck is in our seeding practices. I think the first thing to be thinking about, though, is when we start off the season here, is keep a sample. Minimum 500 grams or 2 cup sample should be seeded from all the crops we've sown. Doesn't matter whether it's barley, canola, wheat, we should be all keeping samples. The biggest thing is here is keep it into a Ziploc bag, put it into a rodent-proof container, and store it in a very cool, dry location. Big thing is for the canola part, at least throw your blue tags in there and throw anything that has related to that seed lot that you've purchased. Big thing is here is that by having that sample is that if something does show up, you at least have a sample to say, you know, is it the seed or isn't it the seed? This year picture we showed last year during our stand establishment presentation, but I still bears worth repeating, And the reason being is that it still would be nice to see more and more people and producers out there grabbing a sample as it's going through the drill. Reason being is that there's a lot of things you can tell. Number one is, are you getting the seed out there in the end? And we'll tell you different things, but I think probably the bigger one here is what's happening to your seed. This is actually a picture I showed last year, and I'm going to show again, is that this is actually seed that was captured coming out the end of the tube. And this was basically under some very high velocities of fan speed, because as producers that I've talked to, they set their fan speed based upon the idea that they don't want to plug. Now you see the splits here, and we know that that will not germinate. What it is that we're always concerned about is the unseen damage that you will not see. Whoops. Very sensitive screen, but it's this unseen damage that we don't see. Now this sample here was into above a 92% germ, but once it was sent to the lab for a quality analysis, it came back in the high 70s for germination after going through. So when we take a look at this sample, what we potentially have lost is 20% of our potential for germination. And so if we're dealing at a 10 plant per square foot target, and we've seeded according to that, and we've lost 20%, we are now looking at a potentially an 8 or 7 plant per square foot plant stand. And so this is why it's really important that we grab to that sample. Now, the thing we have to look at is the reason why we're being so critical about this is that this is from some research work that Murray Hartman did as far as doing a neural net analysis, or meta-analysis I should say, where he looked at all the different trials from all over Western Canada and put them all together to look at what is the critical level to see where the most consistent yields are. And this is one thing that is really proven out here, is that when you start getting below 5 plants per square foot, you can see that you can achieve a top yield. However, your variability really plays a role. And if you take a look at in the far end here, you can see here that if you're down to that 5 and 4 and 3, you can see how the variability is quite large in percentage yield as compared to a 5 to 10 plant per square foot plant stand. And although we've all heard the case where, you know, a producer has said that, well, with 4 plants or 3 plants, I've achieved 45 or 50 bushels. But the big question is, could you have 60? And some of the research work that we did at our production centers here a number of years ago showed us is that we could capture an extra 2 to 3 bushels an acre just by having the right plant stands. And so this is why it's really important. Now, when we start looking at seed survival and seed percentage survival over across Western Canada, you heard Neil earlier talk about 30%. We sometimes estimate it to be 50, but I think one thing that has to be really critical is that what's going to take us from a 30 or 40% seeds survivability up to that 70 or 80. Now, when we took a look at Neil's there, he's talking 30% as a combination of all the different treatments. And what I would tell you is that the drill that they were using for these experiments are 12 feet wide on average. When we start putting across a drill over 60 feet, you are going to see that variability in depth. And you are going to see from 3/4 of an inch to an inch to as much as 2 inches, you know, depending upon your speed and everything else. But when we want to talk about capturing more value for our dollar, when we're looking at high cost of seed and people and producers talking about it's costing a lot for the seed, we have to figure out how to get above that 50% level on average. The other thing that plays a role here is seed size. And when we start looking at a 5.5 gram per thousand seed weight, when we start looking at a 40% survival, we have to be almost into that 7 to 8 pounds per acre to achieve our minimum plant stands. However, just by bumping up another 30% survivability, we can be into that 5 pound per acre to achieve our lots. And so it's really important too, as well, is that when you pick up your seed, you need to be asking what is your seed size so that you can calibrate accordingly. Or if you are going to be dealing with large seed and you don't want to be dealing with going into that 7 and 8 pound class, you got to be able to figure out what's going to take you to that next level. Now, this is a picture actually from northeastern Alberta from last year, where I was called out to take a look at the field. The producer had been complaining to his local seed dealer that this newer variety he had tried was not performing as well as this variety across the road. The variety across the road had come up, was exhibiting at least 10 plants per square foot, was uniform across the field, whereas here what we're looking at here is a field where this is quite uniform across the field, but you can see a lot of open and bare spots. And so the producer was, or he was concerned there was something wrong with the seed. After a lot of examination and discussion, we figured out is that what we looked at here is that this size of plant sitting here, this came from about a 6.2 gram per thousand seed lot, whereas across the road, which was a different variety, was into 4 grams per thousand. So when we did the calculation on the truck hood, what it worked out to be is he got exactly what he had actually seeded for, keeping at his 5 pound per acre seeding rate. Because as it turned out, what had happened is across the road he had taken that variety, calibrated based on this 4 gram, gone out and seeded at 5 pounds per acre, and then not recalibrating, went back and started seeing this new variety across the road. And so what this turned out to be was probably, from what I was told by the seed retailer that I had talked to, he told me that this was at least 10 to 12 days later than a crossroad, even though they had the same variety at the same maturity dates. But the quality, this is all number 2 and 3 that was sitting in his bins with high green seed values into that 10 and 12% green seed. So the producer in the long run at this lost a lot of money because of just not doing recalibration. When we looked at our agronomy about a survey, it did say that 60% of producers are seeding at about 4 to 5 miles an hour, but I guess the question always begs to differ, is this the correct speed? And when we take a look at non-uniform plant stands, now this is a combination of speed, some different runs issues as far as openers, and you can see quite a big pattern, so there was actually a patterning effect going on because of the machinery itself. But the big thing is that we have to be thinking about is that when we're going into this speed, are we allowing our openers to do the best possible job to deliver that seed to the right spot? And so when we start looking at seed, speed, leveling our drills, the big thing here is that we don't want to be seeing this. Now, some research work from a number of years ago from Angadi based on Swiss Current was showing is that this uneven plant stance could be costing us 20% of our yield at the end of the year. And when we start looking at 50 bushel canola and 20%, that's 10 bushels. And you start looking at $10, that's $100 an acre that we could be losing by just not having that uniform stand. Now, this is actually from a producer from East Central Alberta that was trying out some new drill equipment. And the big thing is to look at the left-hand side here, and this is actually his older drill that he normally seeded all his canola with. What he's done here is his standard seeding speed of 4.4 miles an hour. What he did, though, is that this is a new Paralink drill he was trying out on the right-hand side. And although the fertilizer was the same, the seed was the same, everything was the same other than changing up the drill, and he did do the 4.4 miles an hour. You can see we've got some bare patches. Now, the interesting thing about this was all it took was slowing down a 0.4 miles an hour to get all the seed back up where it had to be. When we were looking down the rows and looking inside, we were finding seed from anywhere from on top to down below. And so these are some of the examples of the patches that did show up in the field a little bit earlier. And so by slowing down, we were able to eliminate a lot of this just by going with that 0.4 miles an hour. Now, the question was that, well, geez, I might not be seeing as many acres, but when you're going from 4 miles an hour to on a 40-foot drill to 60 feet at down to 4 miles an hour, you're still seeding the same amount of acres or more per hour. So this is where, when you're looking at new iron this year, you're going to be playing with new iron. You need to be thinking about where is everything going. And my suggestion has been this year for anybody that has purchased new iron is to go out and seed some wheat or seed some peas to get to know your drill, so we don't end up with these bare areas inside our canola canopy that may cause us issues as far as spraying extra or maybe some maturity issues. Now, just to reemphasize seeding speed, I wanted to show you here is that this is actually a trial that I conducted a couple years ago. Actually, it was 2004. Time is flying. But this was back in 2004 with a gentleman that had complained about emergence issues many times. And so what I got him to do was a little experiment. I wanted to ask him to go with seeding speed of 5 miles per hour. Then I asked him to come back down the field at 4 and then go up the field at 3. What came out of this was that after he had done that, I had gone back in and went down the rows as well as across the rows to get a kind of an average. And what we found was anywhere from 1/4 inch to 3 1/4 inches of depth at the 5 miles an hour as far as seed placement. As far as 4 miles an hour, we see all that tightening up of between 1/2 to 1 3/4 would give us a 1 inch average. And then, of course, at that 3 miles an hour, we had some really good uniform depth. Now, I'm not saying 3 miles an hour, 4 or 5 are ideal speeds, but if you look at uniformity for his drill under his soil type, probably 4 miles an hour is sort of the happy medium. Unfortunately, because of the way it was swathed, we weren't able to achieve the yield data that we wanted, but it did show that the producer did say as far as when it came time to swathing, it was more uniform, the 3-4 mile an hour than the 5 mile per hour. And he did say that there was a little bit more patchiness, a little bit more maturity issues. So I'm not going to stand up on my soapbox and say 4 miles an hour is the ideal speed, but the idea is it's to get the majority of seed into the proper depth and to allow your openers to do their job. This is what we pay the big dollars for, those openers, so let's do it. Now, if we take a look at just typically what we're talking about by slowing down a 1/2 mile an hour, if we look at a 40-foot drill, basically 66 passes at a 1/2 mile per hour, that's 33 miles. But at 4 miles an hour, we're looking at 8.25 hours overall. But if by going down that little extra 1/2 mile an hour, we're only losing a couple extra hours, about 6 hours. So the idea being is that 6 hours we're losing may not be as critical, or not 6 hours, I should say 3 hours, I missed it. But the idea being here is that slowing down sometimes with these big drills, we're not really losing that much. Depth control, are you in too deep? One of the things is that we continually see, at least I have seen in my travels, is that we have seen some of the functions of deep seeding, from setting your drill depth on the outside rounds and not checking. But the thing is we have to be getting off our drill continually to take a look to see, are we still achieving depth? Because soil profiles, soil characteristics will change over time. And so the idea being is get out there and check. It may mean going out and taking a look a couple hundred feet behind the drill, or stopping halfway down the field and checking your previous run just to see, to make sure. Now this is actually a picture from a producer that had swore up and down that everything was at a 1/2 inch depth, and it has issues with emergence. But if you take a look here, this is our seed finder. This is actually the 3-inch depth, and you can see the seed is way down here at 3 inches, and this is the reason why some of his emergence issues were showing up. Take a look at this. Is actually a picture supplied by Derwin Hammond that was looking at some plot work that was done through Maffrey, and you can see here that in the soil profile, if we're looking at 1/2 to 1.25 inch average, you see these nice big robust plants. And if you take a look at this 3-inch depth, you can see how that the plants are not as thrifty. There's a lot longer in the root system, which maybe predispose it to more diseases. It comes out sickly, where this is what's going to help us get to our top end yields. This is the kind of plants we want to see. And of course, what sometimes happens from deep seeding is that you do see that we get wire stem. And this is from the fact is that what we have here is, you can see that we've got wire stem showing up down below, and you can see that this is not a function of disease or the seed treatment. This is a function of deep seeding. The longer this stuff stays in the ground, the more predisposed it is to diseases. And this is just to show you another picture of the plot so you can see what deep seeding does for you. And this is, again, a trial that was being conducted, and the fact is that you got a lot of open bare spots. And this is when Neil had talked about resistance and having to respray. This is where all your big weedy patches will show up. As far as soil temperature, 23% of producers use only soil temperatures as a starting point. I always take a look at is that you should be looking at about 8:30 in the morning, 4 o'clock in the afternoon, taking that 1-inch seeding depth. Canola can imbibe water and germinate in 2 degrees C soil, which is 36 degrees Fahrenheit, but the growth rate would be slow, and this is where we sometimes see uneven emergence. I look at a good starting point as 4 to 5 degrees C at seed depth. In some areas, sometimes it may be pushing those limits, but if you are going to be pushing the soil temperature limits, you need to be thinking about keeping your seeding rates up. Seeding shallow, putting some starter pea, giving that seed the best chance possible under these cooler soils. And then just to show you what can happen over time, germination percentage on the left-hand side over days. And you can see here that when we start dealing with the fact of a 2-degree soil, continually seeing that 2 and 3 degrees, within 9 to 10 days, we're still below 20% germination after 10 days. This is creating a lot of issues. As far as uneven emergence, you'll see diseases show up. It gives a chance for insects to find these young plants. If we move up to 3 degrees, you can see we have a little bit more, but when we start into that 4 to 6, you can start seeing by about 6 to 7 days, we're into that 60 to 80% germination. And so this will help us, give us more even fields and get us out of the ground and get us going quicker towards our top end goals. So as far as looking at that, these are kind of things. Now, some of the other factors that we haven't touched on, but I wanted to touch on here, is we have to start thinking about different things. And one of the things we always sometimes avoid talking about at Emergence is what we may have done in years previous or what we have done in the previous spring. I like to show this picture because this is a good example. I've had a few agronomists tell me that using MCPA or 2,4-D, there is a difference, where they said that pre-spraying 2,4-D prior to seeding canola is pulling the trigger, and MCPA is like loading a gun. I disagree. Any of these herbicides, phenoxys, will cause issues. And when we take a look at this, is actually from a field that was taken a picture of June the 12th. This is actually 30 days after seeding. This was actually seeded on May the 12th. And you can see here that it still hasn't moved. Now what happened is the producer, because his dad had gone away with for a number of years, said always putting an ounce or so of 2,4-D. He was trying to clean up some volunteer canola, and we went in with 7 ounces of 2,4-D 5 days after seeding. And so within a couple days after me being out there, he was basically putting it back into barley. Bottom line here is that for MCPA or 2,4-D, it's 7 warm and sunny days and warm soil conditions with good moisture for every ounce of active. So ideally, with the 7 ounces of 2,4-D, the person should have been waiting 35 days to seed his crop. This one here is another field. This is actually seed canola on canola, and this is actually a non-clear field canola being grown on a clear field residue field. And this is actually from a couple of years of Group 2 herbicide, and you can see here that there is a lot of pruning going on and different things here as far as the growing points being damaged, and you do not see too thrifty plants. This is actually plants, this is actually a month after seeding. And so it's really important to be thinking about is that where is my herbicide rotation at too in my canola cycle. This is another example. Now this is actually a producer that had 5 continuous years of Group 2 herbicide and had basically seeded and walked away and then went back at flowering to check it. And this is what the result was. The interesting thing about this one was the producer was quite upset with his dealer for selling him the seed. And so as agronomists that are listening in today, the thing you have to be asking is that when producers are picking up the seed and they've had their fields designated, you have to be asking these questions. What is the chemical history? And if you have been selling the herbicide, you need to be thinking about what a continual Group 2 herbicide can cause as far as your crop is concerned. This one here I like to point out because one of the things that's been happening is that you do sometimes get little mysteries of life. And the one thing I wanted to point out here is that if you take a look at the field on the left versus the field on the right. Now, both of these are the same variety. Both of these fields have had the same management practices. On the left-hand side is the father. On the right-hand side is the son. And you can see this really nice straight line. And it was after about a half an hour walking through the field and going through this, there was something very easy that came forward here. On this side here, what we have here is a top-end variety that was certified, treated. This is basically this is out of the bin run, and this is AC, what I call AC West deal. Even though they're the same variety, you do lose a lot of genetic potential. Now, at the end of the day, this was over 8 bushels an acre on 1,000 acres. So that was a lot of money to be losing. At $10 to $12 canola, that's a lot of money. And the simple calculation is that 8 bushels an acre times 12 is 96 bucks an acre. That's a $96,000 tab just because you wanted to save on seed. So the thing is, what I've always told producers, certified, and we support it. It is the only true legal method, is certified seed. But I also will add is that there has been some discussions and phone calls about talking about mixing seed, 2/3, 1/3, to extend out their seeding rates, and it's still not the best way. I've seen fields where you have 2 healthy plants and 1 dead plant, and that dead plant typically is the one that was out of the bin. That then turns into an open bare patch, which then means that you're respraying for typical weeds. And so certified is always the best, and stick to that. The other one is also being on top of it, and we talk about emergence issues, but this could be a potential problem for this coming year. This is actually from a field from a buddy of mine that we were sitting at our local hockey party year-end wrap-up, and he said he sprayed his field with Roundup, and he says my field's disappearing, and he figured maybe something was going on with Roundup. And you can see in the background here on the right-hand side, this is canola stubble, and it's canola on canola. But I said, well, maybe it's something else. And then upon closer inspection, this is actually from 1 foot square. This is all cutworms, and this is at 10 o'clock in the morning. And what he thought is that maybe something had happened because the Roundup was maybe killing his crop. But this is what was killing the crop, was the insect. So sometimes when emergence issues happen, you have to be thinking about, is it an insect? Could it be wireworms? Could it be the cutworms? And some of the belief is that because we've created such a healthy fall form last year, they're going to be here in big numbers, and so this is the need to scout. And then finally, what I wanted to wrap up with is sometimes these show up, and this is a producer phoning me up saying that this is the allelopathic effect of the breakdown of Roundup killing this crop, even though this is a Roundup ready crop. And I think some of the clues you have to be thinking about, here in the background you can see here all this nice little pasture land here. This actually was a flex wheat patch. And when we walked out there and looked at it, what it actually was flea beetles really hitting the field hard. And just by standing quietly in the field and watching, we could actually see the flea beetles working back and forth along the plants. So what we said, I should spray it within about 4 to 5 days. What it is, the crop came back. The part that was the worst part about this whole problem is that this whole hillside then became its own little separate field, and the producer had to tackle that differently when it came time to swath it. He never did really relate to me about what the yield difference was or anything, but we do know that from flea beetle damage, enough flea beetle damage can cause yield loss at the end of the day. So to sort of wrap up, the bottom line is that we have research that has said that basically a non-uniform stand may be costing us 20%. So if we look at a standard 35 bushel crop, which was the provincial average, you look at 7 bushels an acre at $10 bushel, that's $70,000 over 1,000 acres, and that is substantial economic loss. And I look at the potential is that this is where the gravy comes in, and if we can create and get that uniform stand, we can maximize our potential yield. So with that, questions?
Great. Thanks very much, Doug. I'm just going to switch things over and put up our slide in the background, and then I'll share a few questions. We've got a few questions here. There's a couple of questions that came in at the tail end of Neil's part of the presentation, just asking about, well, one particular question, the impact of soil texture on germination percentage. And then kind of a related question is the interaction between seeding depth and soil moisture, and how do you approach that from an extension standpoint? So I'll maybe open that up to you guys.
Okay, am I on the mic now?
Yeah, we've got both Doug and Neil unmuted now, so feel free to weigh in.
Okay, from a soil texture point of view, the real mellow soils, the ones with lots of sand and silt in them rather than clay, are easier to deal with in terms of canola. We have a pretty, like 35 to 40% sand and quite a bit of silt here at Lacombe, and we usually get some of the highest canola germination levels there, and so the clays make it a little more difficult. Although in a very dry year, you can have more moisture. Now the second question was with regard to how texture and soil, or how soil moisture.
No, it was more around the interaction, I guess, with soil moisture, and I think if soil moisture is low, that interaction between that and the seeding depth message, as far as
well, what we saw was when it's really low, the soil moisture, and you're not really expecting more forecast, then you might have to chase moisture a little bit with canola, but that's a pretty dicey game to play, as Doug suggested, because you get into colder soils and you get weaker seedlings, more susceptible to disease. So we only saw about 1 out of quite a few site years where it actually paid off to chase moisture.
I think to add to that, though, Neil, as well, though, is that in the first 2 weeks of May as you're seeding, if you've got really dry conditions, my suggestion has always been is, seed into the dust and pray. But at the end of the day, if we're starting to get out into that 20th of May time period, and you still got a lot of acres and you got really dry conditions, and the potential for moisture in the future is not as great. The idea is that if you are going to chase moisture within reason, not down 3 and 4 inches, but an inch and a half to 2 inches, you're probably better to seed to that depth to get at least a crop out of the ground, but bump the seeding rates up. Your soils are typically warmer by that time, but the suggestion would be is bump your seeding rates, and that will get you more plants, but it's still a very, very dicey game, and it's really not suggested, but you have to make do with what you're dealt with.
Yep.
Great. Then there were a couple of questions from Chris just regarding all the presentations around the impact on yield and quality of the speed and depth interaction trials, were those all with that same kind of opener? And then a subsequent question was around, if you went to a wider opener, say a spoon that delivered a 4 or 5 inch wide seed distribution, what might the consequences of that be in terms of looking at those factors of speed and depth?
Well, certainly from a spoon versus a knife, you have the chance to throw more soil at higher, and but then again, you know, you're spreading the seed out a little better, and so it can kind of go both ways with a spoon versus a knife. So that's why we're excited to have this new opener experiment starting across the prairies. We'll get some better answers for that. But Doug may want to comment as well.
Well, the only comment would be that I would add to that, Neil, is that as you go to those wider, like to a spoon, yeah, you're going to definitely have a lot more dirt thrown. So actually seed placement is even going to be worse, my suspicion would be. Because number one, because you got a 4 or 5 inch wider opener and you now put even a more excessive speed on it, you're putting a lot of pressure on the system. And, you know, so I would take, you know, I would see that you're going to probably have potentially a lot more variability even then with a wider row spacing or a wider opener. As far as Neil, just comment on the width of drill and the opener and all of the trials. I believe they're all the 1 inch opener.
Yeah, they're all a 1/2 inch wide knife.
Yeah.
I want to make one comment. I don't know if there are more questions, but really what you've seen from an overall standpoint on the data was that it's not always all about yield. Sometimes we rarely get less yield, but sometimes we don't get more yield, but we always get opportunities to not apply herbicides as often and not put pressure on for resistance, and we always go the way of increased quality seed, less green seed. So if you just say, well, you guys didn't get much of a yield bump from doing this, we didn't, maybe 1 out of 4, but we always got a quality bump. We always got earlier maturity, and we almost always had opportunities not to put on so much herbicide.
And I think also to add to that too, though, Neil, is that when we start looking at areas where they're typically under a lot of heavy flea beetle populations or potentially insect pressures, if you are going at the right speed, at the right depth, and you're achieving 80 to 90 plants per square meter, you've got some room for losses. Whereas if you're starting out at 4 and 5 plants and then you get flea beetles, then you get frost, then you're dealing with 1 and 2. And then that becomes a question, is does this plant stand survive, or are we reseeding, or are we leaving it? And then what's the consequences back in September? And that's the biggest thing, is that what we do in the spring sets us up for what's going to happen in the fall. And it continually proves itself out every year.
Great comments, guys. Just further to the opener question, we had a question from Harold about, is there any research planned or any experience up to now with the concept of precision planting and the example they used was the Seedmaster system at lower seeding rates, and what the experience might be with that? Or the other question was, is this going to be included in the study that Neil mentioned?
I can tell you that it isn't planned for the study that we mentioned. We don't have any equipment that allow us to do that on a smaller plot basis. And I think with canola, with such a small seed, it's going to be quite a bit more difficult to make that pay than in a corn planting situation where you can very accurately plant one seed and space it really well. But it's yet to be seen whether that will be an advantage or not. We haven't tested it.
And I can only comment on experience of fields that I've visited, and I will say is that with some of the newer seeding systems, if the time is taken to balance the drill, level it out, take the time to seed it, and still watching our seeding speed, it does produce a nice stand. However, I've also seen where some of the newer equipment in the hands of a person that is still not paying attention to the basics of agronomy, where the stand looks just as bad as with his previous equipment. So it's great to have the new tools, and there are some advantages, and some of the stuff I've seen is showing some good stuff, but you also have to be able to take the time to do the agronomy right, and that means paying attention to precision seeding is paying attention to depth and speed, because it boils down to you still have to allow that opener to do its job for you in your soil types.
Great comments. The next question is probably for Doug. It's a question from Ian, just about in terms of, you talked about saving the seed sample, and so the question is, when you get results back down the road from that, will they be relevant? Because you know, there can always be the claim that any poor emergence or poor germination in that sample might be related to how it was stored rather than the conditions it's seeding. So just comments around what the value of that sample is.
Well, I think number one, the value of that sample is that you've actually collected it at the time when you picked up your seed. And one thing I should have probably pointed out is that that's where you and your dealer that you're picking up your seed from, you should be sitting down with him and collecting the sample together. There are some of the companies that I've dealt with and are dealing with that actually help the producers collect their sample and actually store the sample for them. I don't know if that's a trend, but what it does is that in discussion is that it does give you at least something, because sometimes we hear about where the seed company has their sample and you don't have a sample, so you have to go based upon their results. And yes, storage will be a factor. One thing that was not mentioned is, for example, is if you're picking up your seed, you shouldn't be storing in your chemical shed. Research work out of the U of A that was done out of Dr. Gary Stringham's office was showing us that exposure to 2,4-D for about a week really knocked your germination out. And so the idea being is that it still has relevance to keep that sample with the blue tags, because at least you have something. But sit down with your dealer as you're picking up seed and say, you want to collect a sample and sample some of the bags, and you collect it together so you both, and if you have to, store it. There is relevance is that, like I said, you do have something, but that would be something more along the lines that you need to be talking to your local seed lab about how they want the sample collected, how they want it stored. And the parameters I gave you there were based upon what was told to me by 2020 labs.
Okay. And then from John, we've got a question about any comments on the impact of row spacing in terms of time to reach ground cover.
We generally found, we did some wide row spacing just to look at the chance of reducing disease. So we went all the way from 9, 12, 18, and 24. And when we got beyond 12, and especially up to 24, we really took a big yield hit. And so it's obvious that if you're narrower, you close the canopy a little more quickly. But we didn't see any real difference between 9 and 12 inch, but when we went beyond, we saw some large delays in closing the canopy.
What about follow-up, Neil, as far as weed matter or weed establishment, etc.? Is there any comments on that?
Yeah, in that study we controlled the weeds, but yeah, in other studies, yeah, it's going to remain open and leave opportunities for weeds. So going beyond 12 inches, I think, starts to get risky in canola.
Okay, great comments. And the last question we've got here was just around the use of what might the potential benefits be of seed primers. This question from Reg on emergence specifically. Has there been any work done looking at the impact on germination and emergence?
I'll let Doug answer that because I'm not familiar with that in canola. I've heard of it in wheat and other crops.
The only comment I can offer on that one is that I've been told about it, I've heard about it. All I've had is basically coffee shop discussion or scenarios by producers. The biggest thing I can suggest is that if you're looking at potentially a seed primer, try it. Try 40 acres worth. Put it in a good part of your field. Take a good put it into a good representative area of your field. Try 40 acres worth and put 40 acres a check. And the idea being is that will give you a better handle on whether there is a value. The literature that I've seen on it, in theory potentially makes sense, but I have yet to see any data to prove that's been come across my desk. But the idea is the only way to really determine this is just get out in your field and try some, and that'll give you a better idea.
All right, and I think that pretty much wraps up the questions in the interest of time. Thanks very much, Neil and Doug, for your presentation today. Really appreciate it.